Okay, so let's write this question down by Ushange Uqiniso. It says the boiling points of 5 organic compounds have the boiling points of 5 organic compounds, and they've named them P, Q, R, S, and T. Ooh, they are right and. No, it's not and, it's and T. So let me just write the graph here. We have P, and they say it's pentanol. We have Q, which is 2.2 dimethyl butane. We have R, which is 3-methyl pentane. 3-methyl pentane. Then we have S, which is hexane. Very easy. We have hexane, and we have T, which is pentane 1-ol. Can I just stress something before we answer these questions? Guys, if they have given you a table, this is supposed to be a table, by the way. I just don't have a ruler and all that stuff, but this is a table. If they've given you a table and they have named these organic molecules with PQRST, you must refer to them as PQRST unless stated otherwise. You are showing the examiner that you do not read the question. They can ask you a question and say, between Q and S, what is so and so, right? And then you give the name and say, according between pentanol and hexane, no. You must identify them as such. Taking you back a little bit, when we were doing work, energy, and power, and so forth, if they say block P and block R are colliding together, in which direction will the two blocks move, or where will block R move, your final answer is to say block R will move to the east, to the west, or whatever the velocity is. You must show the examiner that with continuation of what the question is asking, you are following with what they want you to follow. Do not write something else, because when they get to the memo and you wrote pentanol instead of writing a P, it means that she kind of sort of understands, but this is not what we're looking for. So make sure you have the continuation of what they are actually asking you to do. So let's look at the first question. Let me leave this like that. So this is 3.1. It says define. See again, define. Define, explain is not the same thing. You define, it means it does not change. And define the term boiling point. Boiling point. Now, you actually learned this in grade 10. Well, we stress it in grade 10. And I know most of my grade 10s, even in the exam, they wrote boiling point is where liquid becomes vapor. No, that is not the definition of a boiling point, my darlings. You must go and read. So the boiling point is when the temperature is when the temperature at which the vapor pressure, and if you can learn this in grade 10, you will sure well know it in grade 12. The vapor pressure of the substance equals, please don't write this, we will kill you. You write the whole word, you don't write equals. It equals the atmospheric. You must know this off by heart. Atmospheric or external pressure. Okay, very easy. Pressure. So let's see the next one. I think I'm going to have to work here on the side. So this one is 3.3. Okay, first they're actually giving us a statement. I didn't see that. It says the boiling points of Q, R, and X are compared. So they are comparing Q, R, and S. And what are they comparing? The boiling points. They're comparing the boiling points. So now number 3.2, put it in brackets, it says, give a reason why this is fair. Give a reason. Give a reason, which means it is what reason. Let me just, because I can't multitask, give a reason why this is a fair comparison, is a fair comparison. Fair comparison. Now, I wanna explain to you what this is meaning. So we have to look at Q, at R and S, and we look at their boiling points, and they are being compared. And we need to see or to show why is it the correct comparison. Now, I want to make you guys a logical explanation on how you identify certain things. If we were to start analyzing two different types of cars, you can't take an SUV and compare it with let's say a very fast car, right? No, if you're comparing SUVs, compare SUVs. If you're comparing 2-liter cars, compare 2 liters or 1.6s. You cannot mix and mingle, right? So there are certain things. If we are looking at 2 liters, there are certain things we have to look at. We look at the turbo. I hope I'm saying this right. You're looking at the speed, at the rev count, and so forth. If we're looking at the speed of cars, that's what we're looking at, right? It's the same thing when we are looking at organic molecules. When we're looking at boiling points, we have to see whether do they belong to the same functional group? Do they belong to the same homologous series? Because you can't compare something that is a gas to something that is a liquid. It's completely different. So that already when you are comparing things, when you're comparing Tobile and her sister, you must see, okay, are they the same? You can't compare me and my brother. No, it doesn't really work, right? So when we're talking about boiling points, what are we looking at? When we talk about boiling points, you have to look at the intermolecular forces. Remember, the more or the strong intermolecular forces between things, right, means it needs more energy to actually boil it or melt it out. You also have to look at what type of intermolecular forces are there. And another thing you can actually compare it, if I'm thinking correctly, the number of carbons that are there. Because remember, the number of carbons can determine whether something is a gas, it is a liquid, or it is a solid. So like I said, you can't compare gases with liquids and solids and so forth. So let's see, based on Q, R, and S, which is this one. This is Q, this is R, and this is S. Let's see what we can find is the same between all of them. Q, R, and S. Let's see, methyl, butane. Let's see if we can have the same number of carbons. But means there are 4 carbons, and then we have 2.2 dimethyl. So on the second carbon, I've got 2 methyls, which is 2. 2 plus 4 gives me 6. So I already can see that Q has got 6 carbons. Q has 6 carbons. Let's leave some space. Let's write R. Let's see what how many we can find for R. Pent means 5. Meth, on the third one, there's a side chain, which is methyl, which is 1. 1 plus 5 gives me 6. So R also has 6 carbons. And then let's see, let me see if I'm going to have the same space, enough space. But let me write it here. Then we've got S. Hex already tells us it has 6 carbons because it's meth, eth, prop, but, pent, and then hex. So this one has got 6 carbons. So the comparison is true. Let's see what else can we find. Let's look at the name ending. Ane means it's an alkane. Pentane means it's an alkane. Hexane means it's an alkane. So in all of them, they are alkanes. This one's also an alkane. And this one's also an alkane. Let's see what else we have. There is no double bonds in the first one. There's no double or triple bonds, so they are all saturated. So this means single chains. Single chains, which is identified by being an alkane, but let's just write it. Single chain, this one's also a single chain. So remember, if something is a single chain, it means that it has the same number of carbons and it has the same number of hydrogens. So give a reason to why this comparison is true. So this is how I would phrase it, right? I would say Q, R, and S, it's a good comparison because each of them have got 6 carbons, which we have proved. They all belong to the alkane group. They all have single chains. And if something has single chains, it means it will have the same number of hydrogens and it will have the same number of carbons. So this is the reason that you can give. When you're giving a reason, do not say Q, R, and S is the same because of the number of carbons. Tell the examiner what you're seeing with the number of carbons. Tell them they've got 6 carbons. To see, you can see that the side chains, like this one, for example, dimethyl means there are 2 of the same on that side chain. The examiner wants to see that you can look at this number and picture the structure. That's what they're looking for. Remember, chemistry and physics is all about critical thinking. You must see beyond, right? When people are finding cures for medicine and diseases and so forth, they see beyond. So you must also kind of think like that. Show the examiners that, no, man, you can understand that there's no double or triple bonds. It all belongs to the alkane family and so forth. Even though it was from 1 mark, but it's 1 mark that is really pretty simple and very easy to get. So that was the first, that was 3.2. Let's see our next question. Let me go to another slide. The next question for this one says, we have boiling points now. So the boiling points, we have the boiling points. We have the boiling points of Q, of R, and S. So we're looking at the same comparison, right? Are given. Are given. And then here it just says they are not in order. So they've just written it as 55 degrees Celsius. We have 49.7 degrees Celsius. And then we have 68.6. Now, what must we remember? In the first page, well, in most textbooks that I've seen, they give you the properties when we talk about organic molecules. We talk about the property in terms of the chain length, of side chains, of the functional groups, and so forth, right? We also bring in the hydrogen bonds, the van der Waals forces, dispersion forces, and this is taking you back to grade 11. In grade 11, we had an introduction on the different types of forces of intermolecular and intramolecular forces, of what is holding these molecules together. When we talk about boiling points, something that affects the boiling point or the melting point of organic molecules will be the intermolecular forces that are holding it inside. For an example, if I have just a single finger and you're trying to pull me apart, pretty simple. If my intermolecular forces get stronger, you need a little bit more power. If I increase them to a triple bond, you need a little bit more power. It's the same thing when we are talking, or when we're talking about hydrogen bonds and London or dipole forces. They also have their certain strengths. In grade 11, we've learned which are the strongest and which are the weakest, right? And which one form dipoles and so forth. So already when you see temperature, degrees Celsius, think of intermolecular forces. So now let's see what the actual question says before I took over myself. So with 3.3, so which of the 3 boiling points is likely to be the boiling point of R? Let me write it out so you can study better. Which one of the three, wrote that twice, of the 3 boiling points, is more likely the boiling point of compound R, and they want us to explain. Okay, I'm going to break it down for us like this. Let's look at all of them. Let's start with Q. Right now, I'm looking at this paper here, and with Q, let me just go back. I'm using this table here, my darlings. I'm using this table here, and when I'm looking at this table, I'm going to write how many side chains and how many long chains each of them has. That's what I'm going to write. With Q, there are 4 straight chains, 4 straight, and what is important? Remember, if something is a straight chain, it is much more easier to break than something with a lot of branches, because if you just have a straight chain to breaking, you can break it like this, like this, like this. But if something has to break here and also break there and down here and continue breaking and up there, it requires a little bit more than somebody's just going in one straight way. So remember that. So when we're talking about if we have to look at which one will have what boiling point, we have to see which one has the most side chains, which one is more straight, because we know straight will be a lower boiling point. So if I'm looking at Q from the table given, it will have 4 straight because it's bute, but then how many branches? I'm going to have 2 branches. I'm going to have 2 branches. That's why we have the dimethyl, right? And then if I have R is pentane. So I'm going to have 5 straight. I'm going to have 5 straight chains. Guys, if you feel like looking at it like this is a bit confusing for you, you are more than welcome to actually draw out the whole structure. But you must remember, in an exam, you only have 3 hours, right? So you also don't want to waste time. If you can just look at the name and find the side chains and long chains will be absolutely perfect. If you feel like you are struggling, draw the entire thing on the side, right? So with the lack of time, unfortunately, I'm going to do it like this. So with 5, we've got pentane, which is my straight chain, and then on the third one I've got 1 methyl that is branched. And then let's look at S. I've got 6 straight because it's hexane. 6 straight. 6 straight. So most likely that the straight chain will be the lowest, which is 49.7, because it requires less energy. R means then it must be the middle, because it is less than 6, but it is more than 5. So it means then that for R, it should be 55. So which of the compounds is R? It will be 55 degrees Celsius. And your explanation could be it's got 5 straight chains, 1 branched. It's got 1 more than Q, 1 less than S, right? Which means the energy needed. The energy needed is more for Q, but less for R. And remember, if you are explaining something like this, let me actually see how many marks was this for. So this was for 4 marks, 3 marks. If you have to explain between 2 things or 3 things, right? This is how I would explain, or this is what the examiner is looking for. You have to explain R. So now we've found the temperature for R, which is 55 degrees Celsius. And they're asking us to explain why. So you can use Q to explain for R and say that R has got 5 straight chains, meaning the temperature required for Q will be less than R. Or the temperature for the energy required for R will be more than Q. Or you can say R requires more energy than S, and S requires less for R. If you are explaining 2 things, you don't just say Q has got more because it's got 5 chains. In comparison to what? Right? You must show the examiner that you are explaining by using the correct chemistry terminology based on what you were given. Remember, if I can take you back, if you are explaining how fast our 2 liters are, you have to look at both of them and say, my rev count is better than yours, or my speed, and so forth. You are explaining 2 different things. R is so-and-so because it's what with S, or S and this is so-and-so with this. You are explaining 2 different things. You're not just giving out a fact. Yes, we can see you found the temperature, but explain how you got the temperature based on what was given. So that's what the examiners were looking for in this one. So in the next one, let's see what we have here. Now they've given us another one. Let me work on a different paper sheet. So now with this one, this is 3.4. This is actually a long question. Whew, this is Shangik Tuniso's question. So we have a mixture. When they tell you a story more, you must think outside the box. Of equal amounts of P and T. Let me see what P and T was. P was pentanol and T is pentan 1-ol. So it's an aldehyde and an alcohol. So the mixtures of equal amounts of P and T is placed. This is placed in a flask. in a flask and heated to a temperature below their boiling points. This is very important. Below their boiling points, and we must assume that no reaction or condensation. Now, this is a grade 10 terminology when you draw the water cycle, so I hope you can define what condensation is. Takes place, and now they collect it in a syringe. So for everyone at home to see, the syringe looks like this. Ooh, Tobile is not an artist. But here we've got vapor. And then there's like a little tube thingamabobby. And it is going inside a flask. Okay, but technically, and then we have our liquids there. And then in here, they're telling us they've got P and T. So the question in which they're asking us, 3.4.1, which compound, they say which compound will be present in a greater amount in the syringe. Now, I just want to read the question again, and this was for 2 marks to see where can we find our answer. So we have a mixture of equal amounts. Okay, that's the first one. So none was more than the other of P and T. It's an alcohol and an aldehyde. Already, P, what did we say P was? P is my aldehyde, just write an A there, and then T is my alcohol. Now already I know that an alcohol will then have hydrogen bonds, right? It will have hydrogen bonds, and it is placed in a flask and heated to a temperature below their boiling points. So we know if it's below their boiling points, not much really happened, because if something was to boil, then the kinetic molecular energy of the particles will then increase, but if it's below the boiling points, then not really. So then we must assume that no reaction or condensation took place. But then this question says, which compound will be present in a greater amount, greater has an R to be, will be in a greater amount in the syringe. So P is pentanol. Please someone write the name for anyone who just joined us, which is an aldehyde. Okay, I see what they wanted you to do in this question. We've got T, which is pentane 1-ol. So how I would look at this question, I would then say aldehydes have got weaker intermolecular forces than alcohols, right? Because I know this is hydrogen bonds. So which means the one that where we will have the vapor, this is where what will be in the syringe will then be P, which is your aldehyde. This will be my answer. And now I'm trying to think. Remember, alcohols have got stronger intermolecular forces, which require a more energy to break the intermolecular bonds than an aldehyde will have. Aldehydes will form more dipole-dipole London dispersion forces. So then P will have its intermolecular forces broken much more easier than that of alcohol. Now let's see what the next question says. Now they want us to explain. Why we got what we have. We've got 3.4.2. So it says we must explain your answer in 3.4 by referring to the types and strengths of intermolecular forces. So I'm just going to say explain using intermolecular forces. Explain using intermolecular forces. Intermolecular forces. Now guys, you must remember, when we first introduced, or when you were first introduced to intermolecular forces was in grade 11. Explain using intermolecular forces, and this is now for 3 marks. So now we must think like geniuses. Okay, let me see. This is what I would do. I would say P, remember we must explain between 2 things. If P is an aldehyde, we know that aldehydes, well, are more of a dipole-dipole force. It's a dipole. Remember, dipole means one has a positive end, one has a negative end. Where T is an alcohol, it is an alcohol, and this will have hydrogen bonds. Remember, the minute you have something bonded to the hydrogen with and the carbon, then you will have your hydrogen bonds, and there are, I think, 7 types of hydrogen bonds. But now let's see if we can explain this. Explain using intermolecular forces. So if I look at P, I can say P has got weaker intermolecular forces than T, because P is dipole-dipole forces and T is hydrogen bonds. Or you can say dipole-dipole forces are weaker than hydrogen bonds. Or we can do it vice versa. Let me find another color. I can say T, let me find this one. I can say T is an alcohol which has hydrogen bonds, which means it has stronger intermolecular forces than that of dipole-dipole forces. Because remember what we said? If you are explaining, you must explain in comparison to what? We said that P will be in the syringe, that's where the vapor will be, because it has weaker intermolecular forces than that of T. Why? Because P has got dipole-dipole forces, whereas T has got hydrogen forces. What forces are these? These are the intermolecular forces of these two. And I think then we could have actually scored 3 marks. But remember, when you're explaining, you must bring in the one that you're talking about in comparison to what, and using what? Back to this one. And then I think for 3 marks, we could have found the answer. I think with this question, what the examiner wanted to find out, you had to identify that one was an alcohol, one was an aldehyde, and then to say which one will be stronger between the dipole-dipole and then the hydrogen bonds. That is then how I would have actually explained this question.